Good morning, good afternoon, everyone. Good evening, wherever you are in the world. I am Twan van Gerwen, Technical Director within EW Nutrition. Welcome to EW Nutrition's Partner in Progress Connect webinar titled Improving Feed Mill Efficiency and Profitability in the Year 2022. The title of the webinar specifies in 2022 because, let's be honest, this year is not like any other one that we have in the recent history, and this is not necessarily in a good way. It's old ways of doing business need to be adjusted in 2022. Now, in the aftermath of the pandemic, we have supply chain issues, climatic events, and the war in the Ukraine has led to increased raw material and energy prices. General inflation related with that and more. So to discuss the topic of feed mill efficiency and profitability in this particular year, we have an honored guest from North Carolina, USA. Dr. Adam Fahrenholz is an associate professor in the Prestige Department of Poultry Science at North Carolina State University. Dr. Fahrenholz coordinates the feed mill program and teaches courses on feed milling technology, quality assurance, and facility and process management. Dr. Fahrenholz also serves as an industry consultant and coordinates an extension program focusing on industry education, regulatory compliance, quality and process improvement in feed manufacturing facilities. So he's joined by me, the host of today, and by my colleague, Ivan Ilic, EW Nutrition's global feed mill and liquid application expert. So before we begin, an administrative note, please submit questions that you might have in the Q&A message box at the bottom of the screen. We will try to get them answered by our keynote speaker, Adam, during the presentation, where and when appropriate, right? Eventually, we will try to answer as many questions as possible during the Q&A session at the end of today's webinar. But please be ensured that if your question does not get answered due to time limit, we will address it directly to you after the webinar in the coming weeks. We'll start off with the presentation by Adam, then we'll go to let's say, panel discussion session, and we'll finish off with the Q&A. So thank you, Dr. Fahrenholz, for your participation. I would like to give you the stage here to start your presentation.
All right, thank you very much, Twan. I appreciate that. And as I will also say, good morning, good afternoon, good evening from North Carolina. Very early good morning to everybody. And I'm glad to see everybody and have everybody join us. And as Twan said, this is certainly some very key things for us to think about when we think about efficiency with all the changes in the business models and everything that we've had over the last few years. And so hopefully we can have some interesting discussions on things that we can do in the feed mill in order to be, let's say, more efficient in the ways that we operate. So, improving feed mill efficiency and profitability in 2022. When we think about the feed mill and we think about it in terms of an entire system, there are a lot of things that have to go into our considerations of what is efficiency and how are we going to, in fact, be efficient and profitable when we try to operate that facility. We think a lot on the process efficiencies, meaning how we operate our machinery and how we move about the facility in a way that is going to give us the best return on an investment. But when we think about efficiency in a more global sense, we also have to consider things like optimizing manufacturing and nutrition and measuring quality and process variables in a way that gives us the data that we need without maybe taking up too much time or too much cost that in the end will make that data less usable to us from a business perspective. Now, certainly efficiency is important across the entire feed mill. And because we talk about this in terms of the feed mill profitability and efficiency, I don't want to ignore any aspect of the mill. But with that being said, we are going to move through some of the possible efficiencies on purchasing and receiving, grinding, and batching and mixing fairly quickly, so that we can get to the ideas around pelleting, because I think that's probably where the majority of the audience is going to have most of their interest. However, because we're going to move through that fairly quickly, certainly if there are any questions, please feel free to share those. Also, after the fact, because we move through quickly, if there are questions going back to something like, let's say, grinding, please feel free to reach out and ask those sometime in the near future, and I'd be happy to answer those as well. So jumping off, we start with receiving, the first part of bringing materials into our feed mill. No matter what kind of feed mill we are, what type of feed we make, what species, we first and foremost have to get our ingredients and materials into the facility so that we can make feed from them. Depending on the size of our facility and how our facility operates, who and what we are making feed for, we could certainly have bulk receiving, meaning feed coming or ingredients coming in on trucks or rail cars. We might also have bagged receiving. And when I say bagged, I mean everything from something like a 25-kilo bag all the way up to our very large super sacks that might be bringing in larger amounts of material. Either way, there is a certain amount of logistics that must go in to bringing these things in and doing so in a manner that is both timely and efficient, but also make sure that we maintain the logistics and quality that we need in order to keep the facility operating at a high level. Record keeping becomes certainly very important no matter what kind of receiving we are doing, because if I don't have the ability to go back and look and see where something came from and when it came in, it can make things difficult in certainly an instance like a food safety concern, a recall of a product based on an ingredient used. But even just in the day-to-day operations at the feed mill, it can be difficult, because if I don't know when and where it came from, I may have issues with something, let's say, like storage, where I might have required separations, perhaps on things like medications or additives that are only appropriate for one particular animal species. The acronym FIFO stands for first in, first out. So am I making sure that the oldest ingredients, the first ones that came to my facility, are the first ones I am in fact going to use? Do I have my storage set up in such a way that I can make sure that I can get to those materials? And then I also have to consider our environmental conditions. Is it going to be particularly hot and humid, and how will that affect storage overall? Really, when we think about storage and we think about efficiencies or receiving in general, and we think about efficiencies, a lot of it comes down to our quality assurance procedures. We know that if we do not have good quality assurance, quality control procedures, we are either going to bring in poor ingredients, or when a poor ingredient arrives at our door, we're going to have an inefficient process as we try to figure out what to do with it, instead of having something already written down and knowing how to proceed. That's going to lead to cross-contamination, and at best, poor quality in the ingredients will lead to poor quality in the finished feed. At worst, it will lead to a feed safety issue. Now, when we think about from an ingredient input standpoint, and we think about manufacturing versus something like nutrition and feed safety, the more ingredients we bring in, the more nutritional options we have to formulate the feed. And so that's a good thing. However, it also tends to mean more reconciliation, more management of things like shrink, and that's going to be an impact on our efficiency of operations. So how do we balance what is good for the nutritional formulation side of things versus the efficiency of operating based on the number of ingredients we're going to bring in? The same thing holds true for sampling and testing of these ingredients as part of our quality assurance program. The more sampling and testing that I do, the more data I have, the better control I'm going to have of my system. Again, that's a very good thing. However, while I'll have less performance risk at the animals, less regulatory risk for something going wrong, I also have more time and more expense. So more sampling and testing means less risk, but it means also probably less profitability and a lower efficiency. Every facility and every company needs to find a balance there. We also have a lot of tools we can use, digital systems, enterprise resource programs, automation systems, barcoding for inventory so that we can digitally track things as they move throughout the facility. And that can be done on individual ingredients. It can be done on lots of ingredients. It can be taken all the way to our warehouse management so that I can, in any given time, immediately pinpoint where in the warehouse a particular ingredient is being stored. These things can make us move faster and take some of the time out of decision making, especially on something like that first in, first out type of a consideration. Also, rapid testing on the quality assurance side, using NIR, using rapid methods for mycotoxin testing will allow us in many cases to get the data that we really desire on a nutritional and a feed safety side without maybe taking too much time or too much expense, and therefore slowing down the process. Next step in the mill that we are going to think about from a process standpoint would be grinding. When we think about grinding, and most of this is going to hold true whether it be for a hammer mill or for a roller mill, the first thing we have to consider is, are we meeting the downstream needs of the feed mill? If my batching, my mixing, my pelleting, or certainly my loading out of feed is waiting on grinding, then it's not doing its job. It's not as efficient as it needs to be. After that, we also want to make sure we attain the proper particle size, and then, as to the extent possible, reduce our energy consumption and therefore be more efficient from the standpoint of the electric bill and the amount of energy that we are consuming. Again, though, we also have to think about it from the standpoint of balancing the nutrition for the animal and the process at the feed mill. Again, that's going to be a part of measuring efficiency and then ultimate profitability across our systems. When we have smaller particle sizes, we get things like greater surface area, which leads to increased enzymatic digestion inside the animal. Generally, we'll see an improvement in pellet quality and less ingredient segregation. So those are all really good things. But if we can go to a larger particle size, we can lower our grinding cost, which is going to help on that electric bill and that sustainability of our facility. Our handling and palatability of ingredients is usually a little better with the larger particles. And then we can complicate it even more by bringing something like the digestive actions of birds into the equation and saying, hey, when we have larger particles, their digestive features, the gizzard, the gastrointestinal development, reverse peristalsis, all work better. So we have to optimize between the small and the large particle size here. So how do we do that? Well, we can use hammer mill components, things like a variable frequency drive to get the hammer mill to operate at the best possible place for that perfect particle size and distribution that we are trying to attain. On something like the roller mill, newer designs have automated roll adjustments, which will allow us to better control and tweak the particle size exactly where we need it without wasting energy. We also may want to look at, especially as we build new facilities, some alternative grinding processes. So for example, in places other than the United States, that post-batch grinding a lot of ingredients at one time in a batch system, works very, very well when a lot of ingredients need to be ground. Step grinding, doing a roller mill cracking of corn before the final hammer milling, may be more efficient in some cases. We also have multi-streams where we're bringing in coarse and fine particles from different grinding streams that may work well. And then we may have things like inline particle size measurement technologies that are coming on to the market that will help us make these decisions in real time. The next major process, and the last one before we get to the pelleting one that we'll spend, as I said, most of our time on, is batching and mixing. And of course, our goal when we get to batching and mixing is to bring all of the ingredients in at the proper levels whatever the formulation of that feed called for, are we in fact bringing it in at those ratios, at those amounts, and of course, you actually using the ingredients in the correct manner so that we have the proper balance of nutrition for the animal. And then on the mixing side, mixing it to that homogeneity to the point where every meal of the animal is in fact going to be the same. And therefore, all animals that are consuming that feed will have the same input going into their production process. From the process efficiency standpoint, we want to reduce our batching and mixing cycle times to the extent possible. So at some point, we have gotten uniform enough with that feed, and we have gotten precise enough with weighing that ingredient out that to take longer to do it won't actually have a return on investment. Once we've determined where that point is, we do not need to slow the process down anymore. We certainly want to eliminate any kind of ingredient no flow situations where we run out of something upstream or things bridge in bins. We want to flush and sequence appropriately from an animal food safety and a carryover standpoint. Different feeds are going to require different things, but what is the most efficient way to prevent carryover from occurring? Sometimes a flush and actually going through and cleaning the entire facility is necessary. But in most times, doing proper sequencing, just good planning of the day's production can save us a lot of time and reduce those number of changeovers, the movements from one feed type to another that, while may only in some systems take a few minutes, really add up over the course of the day and the week and the month and can really slow us down and therefore lead to process inefficiencies. So some of the strategies on the batching and mixing side, first is to reduce those non-system ingredient inclusions. That meaning effectively getting rid of as many hand-added ingredients as we possibly can and moving to microsystems and toast systems. In some cases, it may just mean having less ingredients or using more base mixing in order to get where we need to go. If you do have to use hand adds, are we using automation-based systems in order to make sure that the hand add operators can move as fast as possible? Are we using proper statistical process control to measure our tolerances? Again, going back to variable frequency drives on motors to make sure that we are running conveyors as fast as possible up until the last minute when we need to slow them down to get just that last bit of precise dosing. And then maybe can we vary that level of uniformity, that coefficient of variation, based on the species of animal, knowing that larger animals can eat somewhat less uniform feed and perform just as well because their meal size is longer. Are there ways to monitor that in line and make sure that we are being as efficient and optimizing the process as possible? From a batching perspective, this would all include ingredient locations, how we've set up all of our automation set points, making sure that our tolerances are as precise as necessary, but not necessarily so precise that they slow us down with no benefit to the animal. And then making sure we're discharging ingredients from the scales in a proper order, that we're not leading to poor mixing. All of those things could negatively impact us from an efficiency standpoint. And that gets us to pelleting, the part of the process that I think most of us think about a lot in terms of measuring that efficiency versus that profitability of our process. There's a lot of money that goes into pelleting from an energy standpoint and from a steam generation standpoint. And so it's a really good place to focus our efforts on making sure that we are operating our facilities in the most efficient way possible. Different ways that we might think about efficiency when we talk about pelleting. The first is throughput, and then that matches up very well with efficient energy utilization. Different people will look at that in different ways. That could be energy usage per ton of feed manufactured, for example. So kilowatt hours per ton is one way we look at it, or tons per horsepower hour might be another way that we can look at it. There are different, obviously, units that people will use, but some measurement of how much energy is it costing me to generate a certain output by mass of feed that is being produced. I'm also going to be concerned about my pellet durability and my pellet quality. At some point, I have to consider, do I need the process to be faster and potentially lose some of my pellet durability and quality, or is the efficiency of my system, and especially the animals consuming my feed, incredibly reliant on that pellet durability and quality, and therefore it rises very high up in the level of my concerns when it comes to the aspects of the facility that I'm monitoring. And then finally, reducing my maintenance costs. There are a lot of things we can do in pelleting that could make better feed and even maybe make the system run more efficiently, but that are going to require then me changing out dies and changing out rolls at a very high clip, which could, of course, be something that becomes cost prohibitive. We know for sure that pelleting is a multifactorial process. We know that formulation factors play a large role. If we have wide changes in ingredients, this could be the moisture in our cereal grains, the amount of fat that we are adding, the type of phosphorus source that we have chosen, and how that helps throughput move through the dye. All of those things will impact how pelleting is being done, as does particle size when we talk about either grinding just the whole cereal grain, or in many cases, again, where we are doing post-batch grinding all of the ingredients together. Larger particle size is going to be less expensive, but smaller particle size often helps us condition better and then get into a better quality pellet. So somewhere in the middle, there is the right place for us to get to. We know we have different processing factors, including dye specifications, throughput, the design of the pellet rolls, our type of conditioner that we are using, and the retention time that we can get inside that conditioner all play a major impact on how pelleting is being done. We know in most cases that to be more efficient in order to have, let's say, that lower energy uses per ton of feed produced, we are probably going to give up something in durability. I have to maybe use a thinner pellet dye to be more efficient, but I'm going to have poorer pellet quality. I need to have higher throughputs to be more efficient, but I'm likely going to have poorer pellet quality. So we have to balance, again, that efficiency versus that durability of the pellet and try to find strategies for things that can maybe help us do both, where I actually get an improvement in efficiency in processing and an improvement in durability and eventual pellet quality at the same time. Those things are somewhat rare, but there are some strategies for that. We also have to be very aware that there are compounding effects. When these different factors interact, it's usually not in a situation where if one thing goes wrong and it costs me 5% in efficiency or durability, and another thing goes wrong and that's another 5%, individually, they might only be a 5% reduction, but combined, they don't add up to 10. Often they multiply on top of each other, and I have a 15 or 20% reduction in my process. So even when something, let's say formulation, can't be tweaked perfectly for pelleting, we need to make sure that everything else is managed as tightly as possible, because otherwise we're going to have these compounding effects. So one of the first things that I always like to talk about when I talk about efficiency and how we operate our facility is the relationship that we have with steam. We have a lot of people think in terms of steam and wet steam or dry steam and what that might mean in our systems. But the reality is, and if we look here at the top, in our line here at the top, that is our energy of steam. And you can see that as we change pressure, which is on the x-axis down here at the bottom, as we change pressure, we actually don't see that much difference in the energy in steam. And therefore, the idea of having at a higher pressure, having, quote, drier steam, more energy per the amount of moisture that's being added, really isn't that big of a difference. On the other hand, we do know that we have huge differences in volume as we change pressure. And those differences in volume are really important, because the more volume that my steam occupies as those lower pressures, the more control I'm going to have using my valves that are putting steam into the conditioner. And the more control I have, the more efficient I can be. Also, at those larger volumes, the steam has to move faster, which also generally means it's carrying moisture with it, and that moisture isn't necessarily dropping out into steam traps and things like that, which is where people might think that they're seeing a difference between dry and wet steam. And really, it's more of a transport of steam issue than the enthalpy or the energy contained in it. Continuing on with steam conditioning, we know that mash particle size has a major impact. As that surface area increases geometrically, as the particle size decreases, we have more places, just like the animal has more places to digest by attacking surface area, we have more places in the feed mill to have the steam enter into the particles and have it absorbed well. So we get that heat and that moisture into the surface of the particles, and therefore start some of the plasticization and the softening so that they can be pressed together. So that mash particle size being smaller gives us more surface area, and that can be a good thing. Now, if we go too small, we can have some issues with pelleting because we kind of make everything more powdery and it doesn't flow well. So there's, again, a place to kind of a perfect spot for most formulations that we can try to attain. Retention time, we can change that using pick angle and shaft speed. Different places around the world, different companies within a given, so here in the US, for example, different companies have different procedures. Generally speaking, the longer the retention time, the better. But again, if we have to slow our system down just to get to a very long retention time, we have to consider to ourselves, is that worthwhile or not? In many cases, maybe 1 minute of conditioning is not going to give us that much of a less of a return from an efficiency or pellet quality standpoint than 1 minute and 30 seconds, at which point it probably doesn't make sense to spend the extra time and energy to go longer if it's going to slow down our process. We need to make sure that our conditioners have the proper degree of fill. If they don't have the proper degree of fill, then we aren't going to have good steam and material mixing, which will lead to poor moisture absorption, poor heat absorption, even if we think we have the proper retention time. We can have all the retention time that we need, but if the conditioner is either overfilled or underfilled, we don't have good mixing with steam, that retention time isn't going to do what we think it is actually going to do because it doesn't have that moisture interaction. The steam characteristics overall, as I mentioned, dry versus wet steam might be a bit of a misnomer, something that's not as big of an issue as people think, but certainly the quality of steam is, okay. So do you have saturated steam, or because of failures in steam traps or failures in pressure reducing valves, is the steam coming in at only 95% saturation with too much liquid water, and therefore that's not absorbing as well into the particles as a steam particle will. Overall, from a moisture addition, in general, our optimum conditioning is going to be somewhere between 16 and 18% moisture, although that will vary depending on the formulation and the process that we have. We usually would want to be 4 to 5%, let's say, being added by the conditioner, which means if I need to get to 18% and due to environmental conditions or the conditions of my feed itself, I might be much lower than that. And maybe I'm only at 11% moisture and I can add 5% and I'm only at 16. Maybe I need some more. Maybe I need to think about adding moistures in other ways. When we get to the pelleting specifically, we know that the formulation impacts the friction. Whether we talk about the dry ingredients or the amount or type of fat that we are adding, as we change formulation, we change the amount of friction that occurs between the ingredient and the die wall inside that pelleting hole. That change in friction will impact things like throughput, okay, and it will slow throughput down if our friction gets too high. If we slow our throughput down, we also will have increased exposure of that feed to what is a very high pressure and high temperature environment, which can cause us some issues in things like nutrient degradation. And maybe in some cases, we've got an efficient feed milling process, but if we have too much nutrient degradation, then the animal consuming the feed isn't going to get what they need nutritionally. And we're going to overall, again, from a global sense, have an inefficient process when it comes to full production of that animal product. We know that this obviously interacts with conditioning. We know that the more moisture we add and the more temperature we get to in conditioning, the more lubrication we'll have moving through the pellet die. But also moisture is a great, is excellent at distributing heat. So if I have more moisture in my product, I am also going to have more heat from the die reach more areas of the pellet, because that moisture moves that heat through better than just the dry feed materials do. So I need the moisture in a lot of cases, but I also have to be careful about going too far with it. Obviously, my die specifications matter. Thicker pellet die means better quality, less efficiency, more friction. And one of the things I really have to wonder about when I'm making feed, again, is that pellet quality or additive stability. In a lot of cases, I may want to have a higher quality pellet, but to get there, I have to sacrifice something nutritionally. And I have to make a decision in my facility and inside my company where the balance between those two things might be. So some of the strategies that we might have to improve efficiencies, first of all, is formulating to actually achieving some pelleting goals. Do we think about, when we are formulating the feed, what ingredient choices are we making? Do we think about the use of something like post-pellet liquid application to either preserve an additive or to put fat on after the fact so that we can have a better quality pellet? Are we using those strategies appropriately and not only focusing on the nutritional aspect of my formulation? Do I have a good relationship within my company between production specialists and nutrition to say, okay, this might be better from a cost perspective and a nutrient delivery perspective to the animal, but it's going to cost us enough at the feed mill that it's not going to be worthwhile. I mentioned friction a number of times. Certainly controlling that becomes important. That involves throughput. It also involves die specs. And we need the friction to make a good quality pellet, but it's also our enemy on efficiency and that additive stability. So we need to determine where the proper amount of friction is going to be to make that pellet hold together to the extent we need to without having those negative impacts. We need to decide what parameters we're going to measure. The easy one is conditioning temperature and certainly energy consumption at the pellet mill. But do we care about also measuring moisture throughout the entire process? Do we care about measuring hot pellet temperature after it exits the die to see how much frictional heat we gained? Are there other places that we should be measuring things so that we can learn more about our systems so that we can better optimize and therefore control the efficiency of these processes? Moisture management becomes a really, really big part of this. As I mentioned, there are a few strategies, and they're usually something around conditioning that allow us to be both more efficient and have better pellet quality at the same time. Doing a better job conditioning does that, as does adding things like water at the mixer may help us when we have very dry feed. And certainly if we have products like surfactants or pelleting aids that can help get that moisture into the particle and therefore really to do its job, might help me on both ends. And so are these tools that people are actually using to the extent possible to manage and therefore improve their processes. I just want to show you a few different slides on some work that's been done here at NC State. This is pellet durability index versus nutrient stability and efficiency. And here you can see that we get a higher pellet durability, and in this case, a lower enzyme recovery for this specific phytase, which is not to say this will happen with all enzymes. But in this case, you can see if we achieve a very high quality pellet, that's great, but we really damaged this expensive enzyme we added. Was that worthwhile to the animal? Or would we have been better off with a lower quality pellet, but having all the enzyme present? We can see the same thing on the energy consumption side. We're very efficient when we don't pellet with a thick dye, or we have a lot of fat, and we get more of our enzyme recovery. That's great. That's a good thing. I'm more efficient and I have my enzyme recovery. You can probably also imagine that because I've got that really low energy consumption, I probably didn't end up with a very good pellet in these cases either, because I was using a thin dye, a large amount of fat, excessive moisture, things like that. that helped it get through the pellet mill. So where is that balance going to be? This is the effect of moisture additions on PDI. Certainly we know that as we get mash moisture up, we tend to improve pellet durability. That's not a surprise, hopefully, to anybody. That's a pretty consistent thing we see across the industry. But there are other ways that we can also consider moisture. Here we have mixer mash moisture that we've added, so actually adding water at the mixer. And you can see we actually didn't see any impact on the energy consumption happening at the pellet mill, but we do see that impact on energy consumption when we add the moisture all through conditioned mash. So we know that if we're going to be concerned about efficiency, we can probably focus on the conditioning side. The good news is that means if I want to add something like a surfactant for something like pellet quality, and I want to do that in the mixer, I can probably do that without having a major impact on my efficiency, because that delivery method of moisture doesn't seem to matter as much to our efficiency at the pellet mill. We know that the moisture impacts, the higher the mash moisture content we have, the more durable the pellet is. That's good news. We also know that if we're adding moisture less than 2%, the method that we added it didn't matter. Whether it came from the mixer, came from the conditioner, made no difference whatsoever. We know that we got better quality or pellets when we had 4% steam versus if we added 4% water at the mixer and no steam at all, or if we did a little bit of steam and a little bit of water. Overall, this means we know that if we increase steam, we can reduce energy consumption and improve pellet quality. If we increase water, we might not see as much of an impact on something like pellet quality or energy efficiency. However, that's not to say that you shouldn't consider adding water or using pelleting aids in those cases. If you cannot get there with the steam, you cannot get to the temperature, you cannot get to the moisture you need to because of the environmental conditions or the conditions of the material, then using those products works very well and is likely to only have an upside on the process, maybe other than having to consider their cost, but is likely to only have an upside on the process, improving efficiency or durability of the pellets. It's unlikely to have any negative effects. So it's always a good tool to try in those situations where we just really are starved for moisture. We know that water is not going to completely replace steam, but as I mentioned, when the temperatures are high or the corn is dry, that water may be beneficial. And I mentioned some of the steam quality implications as well. Some durability and quality versus production considerations. We know that the factors that affect pellet quality and energy efficiency, they likely vary depending on the circumstance we're in. Different facilities have different machinery. They have different environmental concerns. They have different formulations that they're going to use. While it can be difficult to have very efficient processes and good durability of pellets and high quality pellets at the animal, those things are not mutually exclusive necessarily if we manage the combination of factors, okay? Those combination of factors tend to have a significant impact on pellet quality, but less on energy efficiency. So as long as we focus on those things that give us good energy efficiency and we make sure those are being done, we can then look at some of those other things and try to play with them to get to that pellet quality side of things. Really, there's overall a large potential in our industry to optimize the process through looking at predictive models of how my facility operates and what works and what doesn't, and therefore make the right choices for us. Those models may also help us predict the efficiency of enzymes in commercial settings. We know that there's more to nutrient preservation during processing than just mash conditioning temperature. We know now that it has a lot to do with the pellet dye as well. So maybe looking more into dye specifications matters more than maybe we thought it did 5 or 10 years ago. Some of the different markers of the nutritional feed quality might be related to some continuous data that's collected, but if you're only collecting the data and not using it, it really doesn't have any impact or any effect. So make sure that you use the data that you collect. And then the techniques that we implement to improve the physical feed quality, again, thicker pellet dies, lower production rates, things like that, they may be detrimental to that nutritional feed quality as well. So we need to make sure, even as feed millers, that when we are thinking about efficiency in the feed mill, that we are also producing a foodstuff for an animal. And if we are very efficient in how we produce it, but nutritionally it's not adequate to the animal, then we really haven't necessarily done our job. All right, that gets us through pelleting. That was a lot of information, and I hope all of you got some good information out of it, and certainly we'll have a chance for some questions as well that maybe we can answer some more. But before we close out in the next few minutes here, I do want to finish off with just the kind of back end of the mill. Again, going back to that idea that it's not just the processing centers, it's not just the expensive areas of grinding, the expensive areas of pelleting that matter. It's some of the other areas as well that can make a big difference in how efficient the feed mill will be. On a load out idea, however you get feed out of your facility, whether it be in bag or it be in bulk, the first thing is just to keep things moving. Do we know the number of bags, the number of truckloads, the amount of feed per load, again, bulk or bag, that's leaving our facility? And are there ways to increase some of those numbers without necessarily requiring a huge amount of more labor or expense? Sometimes very small differences in improving the logistics, making sure that trucks aren't waiting in line, things like that can have some really, really big impacts. Making sure that feed actually gets to the right place is an underrated thing when we think about efficiency of feed milling. Feed deliveries that go to the wrong farm and the wrong bin can obviously have some pretty big concerns when it comes to the nutrition of the animal. Food and feed safety can be certainly impacted, but it also impacts the feed mill because now I have to deal with perhaps a truck going out and moving feed from one bin to another. That takes the truck out of my operation, which means I'm now less efficient on delivering feed elsewhere. So technologies like remote bin monitoring and systems that tie the load by GPS so that the driver can only unload in the proper bin can actually save a lot of time and money beyond just a food safety and a nutritional aspect for the animal. They can be a big part of just improving the logistics of our operation. Making sure we have good drivers that are delivering the feed and making sure that we're doing those monitoring types of things can really make a big difference in how efficient the back end of the feed mill ends up being, and that the rest of the feed mill isn't waiting and having to shut down because maybe feed isn't leaving as quickly as it is supposed to be. All right, we're going to end on some notes of just general efficiency, things that everybody should think about that aren't necessarily tied to the processing centers. There's a lot of material handling equipment in the facility, conveyors and fans and turn heads. Are those things being properly maintained and turned off when they need to be? Things that are always on, lights, compressed air systems, HVAC systems, air conditioning and heating for our occupied areas, computers, monitors, refrigerators, freezers. These things all take a certain amount of energy. And if I can turn certain things off or run certain things only certain times a day, or if I can find ways to have more sustainable energy usage in any of these ways, those are all things that can make small differences that end up making an impact in my energy efficiency and how sustainable I am saying my processes are. That energy usage and the optimization of it does require a lot of planning and commitment, and that goes from the top to the bottom. So employees have to be engaged in that as well. We also need to consider things like boiler efficiency. Are we making sure that we're keeping that operating as efficiently as possible? Not having losses through the stack, blowdown, radiation. Fuel prices are very, very high. So if my boiler is not operating as efficiently as possible to make that steam that I need for pelleting, I am literally putting money down the drain or putting money out into the air by not making sure that it is maintained and operating as properly as I can. Making sure that everything is properly insulated. And I mentioned traps and condensate return already so that we have good steam quality is important. It also goes to the efficiency of its operation. We have to consider our vehicles, the truck fleets, whether it be our large delivery trucks or our smaller trucks that are running around. Those require fuel, so do forklifts. Are they sitting in the yard and running all the time when nobody's in them and someone's waiting on moving around in line? If so, that might be a place to save some money. Overall, energy management does require planning. On the facility side, that's new construction, it's renovations, it's retrofits. On equipments, it's what are my short-term expenses, but my long-term gains if I do good preventive maintenance. That might cost me some money now that I didn't really think I had in my budget. But if it means I don't have to buy a whole new piece of equipment because I keep this one running for longer, that's probably worth the expense. And then finally, our energy management requires evaluation. Do I audit my facilities? Do I generate results from those audits that tell me how good of a job I am doing? Am I collecting data from both inside my facility and outside? So my energy bills, for example. And am I collecting feedback from my customers, from my production staff, from the folks running my farms that are telling me what is working and what is not, and therefore where might I go find small improvements in efficiency that will lead to improvements in profitability. So in summary, being efficient requires a whole process perspective. I have to look at the feed mill from the front to the back, and I have to think about the small things and the large things to make sure that I can be as efficient as possible. My efficiencies need to take into account the energy that I am paying for, the amount of time things take, the logistics and the number of people involved in the logistics of moving materials around, and then finally, the nutrition of the feed that I am producing. If I, again, am incredibly efficient in how I produce it, but it's not nutritionally adequate because I didn't mix it well, I didn't grind it properly, and I over pelleted, then the animal's not going to perform anyway, and my customers are going to be unhappy anyway. So what was the efficiency worth then? Data is absolutely going to be required for decision making. But again, if we collect that data, we better use it. If we're not going to use it, don't bother collecting it in the first place. And then we need to investigate and make use of available tools. That's technologies for moving things through, and it's tools like additives that can help with pelleting, aids and surfactants and things like that. It's making sure that you know how to analyze your pellet dyes and whether or not they are at the end of their reasonable life. It's being able to collect that energy consumption and put all that into a statistical program and say, hey, is this actually making a difference to me? And with that, that gets us to the end of the presentation. I hope everybody got something, learned something new out of that. I hope we have some good questions that we can maybe take a look at, and maybe we can all learn some more as we go forward. With that, I will turn it back over to you, Tuan.
Yeah, thank you, Dr. Fahrenholz. Thank you for your presentation. I think it's nice how you addressed efficiency, expense, control from so many different angles, more than one could imagine that exists. So I really appreciate that. I think all angles covered here, which now opens up for a short, let's say, panelist discussion session, which will also involve Ivan. I would like to first give the question to Ivan to kick it off. Ivan, why would you add water when you can use the moist coming from the steam? What would be reasons to do this?
Yeah, I think that Adam mentioned that during the PPT. In some cases, you couldn't achieve the good results only by adding the steam. That could be from a lot of reasons. Maybe conditioner is not adequate. Maybe the feed is too dry. Maybe you could. Maybe the temperature is too hot of the meal of the mash feed. So in that case, you couldn't achieve just with moisture. Adequate moisture of the material, so you have to use it. And if you're adding the pure water, that could be problematic from biosecurity reasons. So, like we mentioned, it is always good to mix that with some surfactant or organic acid combination. Sven, your sound is.
Oh,
you're
sorry,
mute.
I was muted. Dr. Fahrenholz, so a question to you now. How do various pelleting factors interact and influence pellet efficiency and quality? I mean, you touched on many of them, but could you give us a short, let's say, summary of that?
Yeah, so as I mentioned in the presentation, we can look at all kinds of different things, including the formulation, the particle size, the dye specifications, perhaps the use of byproducts or co-products that some of us know are useful from a nutritional and a cost perspective, but may not pellet very well. All of these things, in addition to things like environmental factors, the temperature outside, and to the maintenance level of our equipment, will all interact, and I think that's the key word here that I think everybody needs to consider, is that they interact together. Any of these things are not, as I mentioned in the presentation, additive necessarily. It is not that, oh, I know that if I let this pellet dye go for another 50,000 tons, I will lose a certain amount of efficiency and pellet quality. But that's okay. That's still within the range of what I need. But if you do that at the same time as not getting to the proper particle size or not properly conditioning the feed, you're not going to just have another little bit of a decrease in efficiency that is going to multiply upon itself. So if you have any one particular thing, in a lot of cases for us, this is formulation because it might be fixed by nutrition. If I have any one thing that I can't control, it just makes the controlling of everything else that much more important, because those things will compound upon each other. And therefore, I'm going to have a bigger issue than I really need to have if I was doing a good job managing the process overall.
The compounding of factors is making this a very science, right? That's why
Yes.
That's why it is a science, or maybe some would call it an art, to really manage all of this.
Yep.
Then one back to Ivan.
And I don't hear you, but maybe
Sorry.
I could give the answer. Okay.
Let me rephrase.
Sven, I don't hear you.
Sorry. When we dilute with a combination of surfactants and labels, could there be concerns at the customer level not receiving what's on the label? You're compensating the loss of weight. How to interpret then the label text and compare it with the actual nutrient levels in the feed delivered?
Yes, that is a good question, and I think it is related to the question which Mr. Boss asked us about safe level of temperature for enzymes destruction. So by adding the surfactant to water, it is most typically not dilution. It is because if you don't have the moisture, that feed is too concentrate. It is quite opposite. And the question is more for the nutrition when they are making the recipe for the feed. If they are calculating with very low level of moisture, and I doubt that is the case, then in that situation, that feed is more concentrated and not diluted. So by adding the moisture, you are reaching what is calculating in the recipe. And also about labeling and enzymes and destruction of the enzymes during the pelleting process and high temperature. Like Adam mentioned, especially from broiler feed or some type of feed, you have to go with higher temperature for the pelleting. So depends how much that ingredient, that enzymes is affected by the temperature. Is it protected or not? Is it coated or not? Those type of question. And what is most typically done, the nutritionist, if they are having the lower quality of enzymes, they are adding a little bit more because they calculate it will be destroyed during that process, some part of it.
Okay, so you're really saying to actually have the nutritional specifications as developed by the nutritionist, you need to add this often to compensate for losses in the process, right?
Yeah.
And then the other impact on the stability of specific feed ingredients on top of that also being impacted by this. Okay, good. I would like to have a last question, see if we have some time to look at the Q&As after that. So Ivan, you can start looking into the Q&A and pick your first question there. I have a final question for Dr. Fahrenholz. What strategies are available to balance, on one hand, efficiency, the feed mill efficiency, and nutrient quality? You spoke already about that interaction and dialogue between production manager and nutritionist, but can you give us some suggestions on what is the most important thing there?
Yeah, sure, absolutely. So one of the things that, and I alluded to it in the presentation, in some of the slides, comes from some very recent research work that we did. One of the things that we've learned a lot about is that most of, when we talk about pelleting specifically, so I mentioned on the grinding side, for example, making sure that we balance our energy consumption for getting to a specific particle size with the needs of the animal. Perhaps for swine, we might want to grind very fine, but for poultry, maybe grinding very finely isn't good for them nutritionally either. So certainly there are things there. On the pelleting side, what we have learned is the vast majority of the impact, if it's going to be negative on the nutritional, actually happens as things pass through the pellet die. It's not to say that conditioning doesn't have an effect. It absolutely does, because it's adding that moisture and it's allowing for some of that heat transfer to happen. But the majority of the actual impact happens between the time the feed leaves the conditioner and the time it comes out of the pellet mill. And so strategies that involve measuring, as I said, the amount of temperature increase, and therefore that's tied back to friction that's happening, using things that might help feed move through the pellet die that don't negatively impact something like pellet durability. So something like fat, for example, I can use more fat. I can put that through the pellet die. The pellet mill runs easier. I'm less likely to have nutrient degradation. I'm also not going to have as good of quality of pellet. What are those things? Again, moisture management becomes a really big part of that. That can do a little bit of both. Also, I mentioned things just like having the proper die specification, but also making sure I'm maintaining those pellet dies. One thing that we see a lot of people do at the expense of the pellet die is high enough, we're going to run it for absolutely as long as possible. Well, at some point, you're at a diminishing returns, and it would have been a lot less expensive to have bought a new pellet die and therefore have had higher throughput, reduced the overtime hours of your employees, and you would have had less frictional heat and been destroying nutrients. And so you thought, oh, I didn't want to spend here in the US, let's say $12,000 to $15,000 on a pellet die. But while you weren't spending $12,000 to $15,000 on a pellet die, the last 2 months you spent an extra $20,000 on production and lost nutritional viability. That might not have been a good decision. I would also say, and I'm going to answer a number of questions. I think kind of one time as I'm looking at the Q&A.
Right.
And Yvonne, if you want to answer any of these specifically,
go ahead,
by all means as well. But there's a lot of questions in here about, and I get it, and I want everybody to understand, I understand, I absolutely get it. But there's a lot of questions in here about, well, how much of a percentage increase would this be? Or what would be, how much energy could we save here? And I'm going to tell you, and Tuan, you mentioned the art versus the science. And I tell my students all the time, it's an art because maybe we don't know all of the science yet, okay? But because we don't know all the science yet, there is still an art to it. I'm going to tell you in the answer, and I know this is a frustrating answer, in almost all those cases, my answer to you is it depends. What is going to work in one facility, you might try a strategy, any of the strategies we've mentioned, and see a 3% improvement in your overall process. That feed mill just down the road may try that exact same strategy and see no impact whatsoever. When I talked about all those interacting factors, that's what I'm talking about. That small difference in equipment, that small difference in formulation, that small difference in steam quality because one feed mill's trap works and the other one doesn't, is going to mean that one facility saw an improvement and the other didn't. So to say for any of these questions to say, oh, we could see a 20% improvement in energy, or oh, the actual normal kilowatt hours per ton would be this, it's going to depend for every facility. And so that means every facility needs to learn how to model their own process, because their model is going to be different than somebody else's.
Good. No, Adam, and I appreciate that you try to address many of the questions in the Q&A, because we got quite a number of Q&A questions. I will take 5 more minutes. I know people that are, it's officially now ending, but for those that are able to stay on, I'll ask Ivan to answer a question from the Q&A. Of course, to all of you, the recording will be made available in a few days on our website. So if you want to listen to this last part, but you have to leave the call right now, the webinar, you can go there and listen to the last few minutes. But I think in respect of all the people that have joined and submitted questions, Ivan, please, I'll give you a chance to answer a few. You're muted.
I will use one question as a good example what Adam said a little bit earlier. It is question, is it possible to reach 13% humidity with 2 mm pelleting without using surfactant? Is there any concern about water activity level and how to test it correctly? It is basically what Adam told. We need all data before that, what kind of equipment they have, what kind of the dye they have to get the answer. The answer could be yes, we could reach 13% of moisture, but without knowing all the other parameters, it will be just assumption. So we know how to reach it, but we need all kind of data to give the correct answer about that. And it is also, I understand, it is always concern about water activity level when you are adding water. So in the case with adding surfactant, so the question is without using the surfactant, or any kind of organic acid, it is a big risk of water activity. By combining two together, you're not having the problem with water activity.
Thank you. Adam, you would like to pick one specific question from the Q&A to finish off with, or Ivan, you have another one that you would love to answer?
I want to answer this. There's one in here I would like to answer. I'm going to answer the question. I'm also going to take it a little further. So someone asks how to measure gelatinization. There are a number of good ways, in fact, to measure gelatinization. There are a few different enzymatic tests different companies can do. Dynamic scanning calorimetry is one thing that we've used here. So there actually are a number of different ways. Different companies are out there that can help with that. Certainly a number of laboratory companies can help. The other thing that I'm going to say, though, is that that question has been a question for decades about gelatinization. And it's a very interesting one. I can tell you that the vast majority of data would show that for most feed types, the degree of gelatinization does not necessarily correlate with pellet durability and pellet quality. You have to keep in mind that we are not talking in this case about extruding. We are not talking about expanding. At the percentage of moisture that we are getting to and the temperatures that we are at, we are not in most cases getting to the point of cooking material. If you take a rice and you put it in some water that's 85 degrees Celsius on your stove and let it sit there immersed in water, it will not cook. It will not gelatinize. You did not get hot enough. That is likely true in pelleting as well. And in fact, data has shown, we've just recently done some here as well, but there's data going all the way back to the early 1990s that Most gelatinization actually occurs in the pellet die, and it's occurring due to the frictional heat between the die wall and the pellet. And therefore, most diets that have high degrees of gelatinization in pelleting, again, not extruding or expanding, but in pelleting, most diets that have high degrees of gelatinization are those that were not properly conditioned. They do not necessarily have good pellet quality or durability, and they were likely less efficient to produce. So I will caution everybody that's here to be very careful about using gelatinization as a benchmark for saying that good pelleting occurred, because it might not be the benchmark that you think it is.
They might go against each other actually
Yeah.
Because the gelatinization is promoted by more friction, and you are avoiding the friction when you try to improve the efficiency of your process. Yeah.
Absolutely.
Great addition. Great addition. It's time to wrap up. I would like to thank all of you. I promised to stick to the 5 minutes, and so I would like to do so. I thank Dr. Fahrenholz for his great presentation. I thank all of you who took the time to be here and raise all these interesting questions. We'll review if some of the questions were actually not addressed during the session, and then we'll pick up on these and get back to you on them. I thank you all for your participation. As I said, recording will be available, and you can make others aware of that as well. It's on our website under Info Center, under webinars, sorry. And for now, I would say all have a pleasant continuation of your day, and a good night to our keynote speaker who has joined us in the middle of the night from the US. And stay safe, keep up the good work. Bye for now.
Thank you, everybody.